Howdy folks, we're now at stop 2, what I think I've described as the river overlook. And Ryan, if you want to take a quick pan, you can see why it's called the river overlook. That is the mighty Deschutes River down beneath us. Those houses on the opposite side are on Aubrey Butte, and we are again on the Bend Basalt Flow, the 75,000-year-old basalt flow. So at this point, we're trying to reconstruct the order of events. What happened? Clearly, there's a deep canyon in front of us with a river, and hopefully we know that rivers cut canyons. They cut down into rock and create canyons. So the question is kind of which came first, the river or the lava flow? So I'm going to throw out two hypotheses, and then we're going to test them. So the first hypothesis is that the river was already here. 75,001 years ago, we're standing here and looking at the river in Aubrey Butte, and there's no lava flow here. And then the lava flow comes here, and it runs into the river and gets chilled. You know, water plus lava make it turn into rock. It gets chilled and ends right here. So this is 75,000 years ago. The Deschutes River's right in front of us. I can jump into it, and the lava flow ended at the Deschutes. And then since then, it's cut further down. So that's hypothesis number one. River was already here. We're good geologists. We want multiple working hypotheses so we don't bias ourselves towards only looking for one line of evidence. Hypothesis number two is the lava flow came in first. The river was not here. The lava flow went all the way up against Aubrey Butte, and then the river came in on top. So river second. So first hypothesis, river was here first. If that is true, we should be standing near the edge of the lava flow. The river was like right there. If I took a flying leap, I would jump into it. I'm not going to do that because it's not anymore. So for that one, we're going to take a look at the edge safely and try not to fall off and see, does this look like the edge of a lava flow? Just like we saw at stop 1. So let's take a look. All right, folks, so as Ryan gets the camera into position, I'm going to remind us of some things we saw last time at the edge of the lava flow. So remember the gas bubbles give us a clue. If we see lots and lots of gas bubbles, we know we're at the edge of the flow. If we see just solid rock without any gas bubbles, then we know we're on the inside of a flow. And then also the shape of the layers. If we see horizontal layers, we know we're in the middle of the flow. If we see those curving layers that curved over the edge, like we saw at the last spot, then we know we're at the edge of the flow. So based on that, I'm going to let you guys come up with your own conclusions from those observations. And actually, I want to hear, Ryan had an objection to this testing of the hypothesis. Ryan, do you mind sharing what that was?
I don't remember what it was.
Ah, okay.
Oh, no, I do. So how...
Give Ryan some FaceTime here.
How would we know if we aren't on exactly the edge of the flow? Because since we know the river has cut down in the meantime, how do we know the flow didn't end 20 feet out in space and is now gone? So there's no way to prove that didn't happen.
Good question, Ryan. You make an excellent point. Yeah, so this is how we practice science. We come up with ideas and then we shoot them down. So yeah, even if we decide that we're not at the edge of the flow, that doesn't rule out hypothesis number one. It's possible that the river was maybe just 20 feet out there and we've lost that edge. So we've got some evidence against hypothesis number one, but we can't be conclusive. So what does this mean? We need more evidence. So let's talk about hypothesis number two. Hypothesis number two, the lava flow comes all the way out to Aubrey Butte and then the river comes in on top. This is fairly common historically. Lava flows dam rivers and then the river goes on top of the lava flow. So evidence that would support hypothesis number two. One, the edge of the lava flow should be way out there. So what we see around here should look like the middle of a lava flow. So refer back to our previous our previous close-up, looking at it again. What do the gas bubbles and the flow layering tell us about whether we're in the middle at the edge? But here's the second piece of evidence that we can look for. So rivers do something very special to rocks. They round them. They take a sharp rock and they tumble it along and smash off all the edges, and you end up with a round rock. There's only one other thing in the world that does that. That's a beach, the waves at a beach, and obviously we're nowhere close to that. So let's take a look for some round rocks. All right, folks, so that was actually a very representative look, even though we only looked at a few feet. What you just saw there is what this whole area looks like. So I think that actually summarizes us here. So what you want to be thinking about is which hypothesis is better supported at this point.